All right, here we go, guys. Imaginary numbers or intro to imaginary numbers. All right, guys, let's focus. Let's focus. Let's focus. It's not scary, so don't worry if you think it is scary. It's not imaginary in the sense that say like the word literally means like it doesn't exist type of thing. That's not. It's just a word, guys, that they give, and literally the definition of imaginary number is just to take a square root of a negative number or a negative one. Because before today, you cannot take a square root of a negative number. If you try to do that on a calculator, so let me take out this calculator here. I think it's in regular mode, but just in case, I'll reset it. So check it out. Here's my calculator, and if I try to it's because we did imaginary before. Okay, so here we go. If I try to do square root of a negative one, look what you get. You get an error. It says non-real solutions because that's what we call, right? Like square root of one is a real answer, which is a one. Chop, I thought you said imaginary doesn't mean okay. It's just a word, guys. So here it is. If I click on mode and I click in imaginary, you see where it says real. And if I go to a plus bi, this one also works. The re raised to the power theta I, but that's more like for engineering. So a plus bi, and I go again and I try to do this one again. Now look, it gives me I. So the literal definition of the square what is an imaginary number? The square root of negative one is imaginary, and we call that I. Well, it doesn't mean imaginary like doesn't exist. That's just a name. It's just a word. It has meaning. You see these AC currents? It's out of phase. It's out of phase with voltage and current by 90 degrees, and they use imaginary for that. So for those of you that are going to take control systems in the future, just Google control systems with imaginary. In engineering, they use the letter J. So anywhere you see the letter J, that's imaginary numbers. So for this power to exist, they had to use imaginary numbers. Yeah, I know. We're not there yet. When you become an engineer, come talk to me. Not that I'll be able to hang. You'll probably be way above me, but I still remember. Okay, are you guys still okay? Remember that square root of happy face times square root of happy face is just happy face? Chav, why are you telling us that? Well, if I tell you that I want to know what I squared is, well, remember that I is just the square root of negative 1. So this means the square root of negative 1 times the square root of negative 1, which is just negative 1. How do we feel? And if I tell you what's I cubed, well, I cubed is the same thing as I squared times I. I know that I squared is negative 1. So negative I. Is this kind of cool? And if I tell you what's I to the fourth, well, I to the fourth is just I squared times I squared. And didn't we already say that I squared was negative 1? Negative 1 times negative 1, 1. And then if I go I to the fifth, and you can see where we're going with this. You can go with this forever. That's just I to the fourth times I. And I to the fourth is just 1. So 1 times I. So look, you're just back at I. So I to the fifth is like I. So I to the sixth is like I squared, which is just negative 1. I to the seventh is like I cubed, which is just negative I. I to the eighth is like I to the fourth, which is I squared times I squared, which is just 1. And it keeps going forever and ever and ever. Is this making sense to you guys? Yeah, nothing crazy. You see? Nothing crazy. So in essence, you can just memorize that right there. Imaginary number is just a square root of negative 1. This was invented, not discovered. And now we see a lot of applications for imaginary numbers, especially in engineering, especially with current, especially with electronics. If you Google later on control systems engineering, and you'll see imaginary numbers all the time. In engineering, they use the letter J and not the letter I. Why do they use the letter J instead of I? Can you guys think of a reason? Well, why does in engineering they use the letter J instead of I? Because what does I mean in engineering? You never you did it in physics when you were doing no. What does I mean in physics? No, not initial. Have you guys done something like this? It's a circuit. And what do they call? Do you guys ever do Kirchhoff's law? No. Oh, V equals I R. You guys haven't heard of that? Oh. Okay. I in engineering is current. So they use it for current, guys, milliamps, amps. When you start doing circuits, series and parallel in physics, you'll use the letter I for current. So in engineering, they can't use the letter I because I already stands for current, so they have to use the letter J. Cool? Okay, here we go. Yes, what's up? To remember. Don't worry. Look, you're gonna learn it. So like, it's gonna be. Okay, just remember. What's square root of -1, Ms. Rodriguez? I. That's it. You're good. See? All right, guys. What's a complex number? I'm just going down the alphabet. A plus minus B, and I put a little I on it. A complex number has a real component. The A is called real. And the BI together is called the imaginary. Chav, I thought you said imaginary is just a word and doesn't mean, so why is this real here? Guys, remember what a real number is? We've been talking about real numbers since, I don't know, when did they introduce that to you guys? 6th grade? Rational, irrational, all that. Okay, so it's just a name, guys. So real components, that's like what we deal with all the time. And then this imaginary part, the I is what makes it imaginary. You'll see some textbooks call the B just a coefficient. Plus, minus, imaginary come in binary components, A plus 3I, A minus 3I. Maybe you heard the word conjugate. We'll get into that later on. But what makes this a complex number? That it has a real and an imaginary part to it. So that's why it's called a complex number. Nothing crazy. Are we okay with that, guys? Yes. What makes it a complex number? You have a real component, which is this right here on the left-hand side, and you have an imaginary component, which is this on the right-hand side, the BI. The I is what makes it imaginary. And the B can be anything. It could be square root of 3, could be 5, could be real number, could be rational number, could be an irrational number, but it could be anything. We still okay, guys? Okay. Check it out. How do we add or subtract complex numbers? Relax. You already know how to do this. You add the reals with the reals and the imaginaries with the imaginaries. So in junior high or in, I don't know, middle school or 5th grade, you heard something called combined like terms. It's the same. It's the same. So notice I have a plus symbol here. So nothing gets distributed. I can just drop the parentheses. 1 minus 6i plus 12 plus I. We can just drop the parentheses, drop it like it's hot, the way Snoop Dogg says. All right. Next, you see that 1 and that 12? Those are both real, so we just add them. What's 1 plus 12? 13. And then I see a negative 6i, which is imaginary, and I see an I, which is also imaginary. So negative 6i plus I is negative 5i. The difference between 6 and 1 is 5, and the 6 is bigger, so negative. And there it is. That's it. We just added them up, and that's my complex number when I add them up. Cool or not cool? Yeah, very cool. Let's look at the next one. It says simplify the expression to a plus bi form. So there it is. They just want a complex number. So I'm going to distribute that negative there. See, I have a minus, so distribute it. So negative 5 minus 6. I just dropped those parentheses because there was nothing in front. Distribute the negative. Minus 10 minus I. Do you guys see what we did there? Okay. Then I see a negative 5 and a minus 10. I can combine like terms. They both have the same sign, so we're going to add them and keep the negative. What's 10 plus 5? Negative 15. Well, 10 plus 5 is 15, but keep the negative. No, you're right. You're good. You're good. So negative 15. Are we okay there? All right. Now I see a negative 6i and a negative I. So add them, keep the negative. Negative 7i. So minus 7i like that. And there it is. See? Are you finding these complex numbers to be hard, imaginary numbers to be tough? No, see, they're not that bad. See, I got you, Rodriguez. Is everything pretty clear? I told you, miss. Chubb, I don't want to multiply complex numbers, Chubb. Yeah, I see that, Garay. That's a demerit. Let the record show that Garay just yawned in my classroom. All right, here we go. I'm multiplying. All I got to do, guys, is just what we've always done. What do your junior high teacher call it? FOIL. Negative 11 times negative 3. Negative times a negative is a positive, so 33. Negative 11 times negative 9i. Chop, I don't know how to do that. Well, 11 times 9 is 99, and there's an I there, so I'm going to write plus 99i. Does everyone see what I did? Okay. I'm done with the 11. I go to the negative 5i here. Negative 5i times a negative 3. Negative times a negative is a positive, so that's going to be a 15, and then I put 1 next to it. I. And then I see a negative 5i times a negative 9i. So plus 45, and then I times I. There it is. We're going to combine like terms. I'm going to go slow. We are going to do something different on this one, but hold on. Hold your horses. Well, we don't have horses, but 33 plus. Here you go. And don't worry. I still remember the 5. Okay. 99 plus 15. What's that? 114, right? Yes. Plus 45, and notice I didn't write the I squared. Chop, what are you cooking? All right. Look, up here, what did I told you that I squared was? Negative 1. So that's what I'm going to replace I squared with. Negative 1. I'll put it here on the side. I squared equals negative 1. Are we still okay? So now I have this. I have 33 plus 114i minus 45. And I'm going to combine these two because now I got 2 real numbers there, see? And I'll wait for you guys to catch up. The difference between 33 and 45 is 12. Let me check. 33, 43, 45. It is. The 45 is larger, and there's a minus in front of that. So it stays negative. So my final answer, I'm going to put an equal sign. Negative 12 plus 114i. And there's my answer. Do you guys see how we did it? Yes. Okay. Now, I don't want to show you this, but I will. But only use this to check. Don't use this to, because there's going to be times, guys, that you're not going to have a calculator. Maybe a TSI, maybe an exam that the professor gives you. Can you type this in the calculator and get this answer? Yes, you can, but make sure your calculator is in degree mode. If it's not in degree mode, look, I'm going to put it in real here, and it's not going to do it in real, or it might. Let's see if it does it. Parenthesis, and I'm going to type in negative 11 minus 5i. Negative 11 minus 5. Chop, where's the I? Alpha I, right there. See? Oh, second I. There it is. See? See where the dot is? And then open. What's the other one? Negative 3 minus 9i. So negative 3 minus 9i. I did take it out of imaginary mode. So let's see if it does it. Yeah, it does it. Regardless of whether you're in imaginary mode or not. But be careful. Wait, where's the I? The I is where the dot is at. Only use it to verify, guys. Don't use, like, I can tell if you're using it on Delta because you do it like so fast. Try do it by hand first. And could you always trick the system? Of course you can, but try not to. All right. What if a complex number is raised to a certain power? So notice that this power is raised to the 4th. Remember what that means? I think that's the highest it goes to. Oh, well, it can go to as many higher powers. But on the assignment that I gave you guys today, the Delta, it doesn't go higher than 4. I put all level 1s. So could you do this with a calculator? Of course you can. But remember what that force power means. That force power means that I just got 4 of them. Yay or nay? Yay. Oh, that sounded so sad. We can do better. We can do better, guys. Does this make sense? Yay or nay? Yay. All right. Yay. There we go, YouTube. I promise my kids are having a good time. At least I hope they are. All right, so look how simple, look how fast we can be with this. What is 1 times 1? 1. I'm doing these two first right here in blue. And then 1 times 2i, that's 2i, but I'm going to have two of those. So can I just go ahead and write plus 4i? And then 2i times 2i, that is going to be, no, 2 times 2 is 4i squared. Do you guys see what we did? Cool or not cool? That's for those two in blue. Maybe I should have done that in blue, right? So here's my parenthesis in blue. And then burnt orange is going to be the same. 1 times 1 is 1. 1 times 2i is 2i, but I'm going to have two of those, so 4i. And then 2i times 2i is going to be 4i squared. Cool or not cool? Chop, now what? Okay, you take this 1 and you multiply it by everything on the right-hand side, on the burnt orange one. So 1 times 1 is 1, so 1. 1 times 4i is 4i. And then 1 times 4i squared is 4i squared. Do you guys see what we did? Or maybe you know what? No, time out. I can make it easier for you because maybe you guys don't like 3 terms. Let me erase this. Ciao. It is correct. It is correct. But I want to make it the easiest possible. Remember that I told you guys that I squared is equal to negative 1? So you see that I squared right here? I'm going to turn that to what? And I'm going to do the same thing with this I squared. I'm going to turn that to negative 1. What's 4 times negative 1 is negative 4, yeah or nay? And what's 1 minus 4? Negative. So look, check it out. I'm going to write it negative 3 plus 4i. That's that one in red. And the one in burnt orange is going to be the same. Negative 3 plus 4i. And do you agree that this is way easier to do because now they're just 2 terms? We can just multiply them? All right, here we go. Negative 3 times negative 3. 9. Negative 3 times the positive 4i. Negative 12i, but I'm going to have how many of those? 2, so minus 24i. Do you guys see where I got that from? And then positive 4i times the positive 4i. Perfect. And we know, what do we know about I squared? It's a negative 1, so I'm going to erase it. I'm going to put a negative 1 in there. So that's going to turn that 16 into a negative. Right? The difference between 9 and 16 is 7. Right? Because between 16 and 10 is 6 plus another 1 is 7. So negative 7. So here's my answer. Negative 7 minus 24i. Could the calculator do this? Yes, but guys, try to do it initially by hand. Let's check it. Look, I'm just checking it. I'm just going to go parenthesis 1 plus 2i. I close the parenthesis and I put it to the power 4. Bam. Did we get the same thing? Yes. How do we feel? Okay. I know the calculator can do this, but try to do this by hand, guys. So this 3 there, don't worry, we're almost done. We got 1 page left. That means 2 plus 3i times 2 plus 3i plus 2 plus 3i. Are we okay so far? I'm going to take these first 2 right here. Chav, why are you doing those first 2? Because it's really simple to do 2 of them really fast. What is 2 times 2? 4. And then 2 times 3i, that's going to be 6i, but I'm going to have 2 of those. So instead of 6i, I'm going to write 12i. And now what is, I already did this part because that's the way I doubled it. 3i times 3i. 9i squared, parenthesis, and then 2 plus 3i again. I'm gonna turn that trinomial into a binomial. I'm gonna put up here, I squared is equal to negative 1. So I'm gonna erase that I squared, and I'm gonna turn that to a negative 1. So that means I have 4 minus 9. 4 minus 9. That's gonna be a negative 5. Oh, because I have 2 of them, miss. 2 times 3i is 6i, and then look, see, I have another one. 3 times 2, another 6i. So 6i plus 6i is 12i. All right, I'm pretty much done, guys. We're going to do the same thing with this one. I'm going to go ahead and show the FOIL on this one completely because I have different terms here. Negative 5 times 2, negative 10. Negative 5 times 3i, negative, perfect. 12i times 2, plus 24i. 12i times 3. Oh, I don't know. There you go. My final answer. Let's see if we can add them up. Well, let's turn that I squared into a negative 1. So I'll go ahead and erase it right here and turn that into a negative 1. So negative 10 minus 36, that's going to be a negative 46. And then 15 and 24, the difference between that is 9. And the 24 is bigger, so plus 9i. Negative 46 plus 9i. I'm going to check my work by typing this into my calculator. Parenthesis, 2 plus 3 second I, close it, power 3. And voila, did we get the same thing? Yes, we did. Okay, don't worry. Last ones. Look at the last page. Last page, guys. They can be in square root form. Relax, we're going to go slow. So that square means parentheses, square root of 5 over 4 minus square root of 5 over 2. And I don't like the I being in the back, so I'm going to put the I right here in the front. Because sometimes that square root stretches a little bit too much, and it includes the I inside. I don't like that. Are we okay so far? So look, I'm just going to put it again because that's what that 2 means. Square root of 5 over 4 minus I square root of 5 over 2, close. I'm going to go slow, guys. I'm going to go slow. Square root of 5 over 4 times square root of 5 over 4. Yep, so 5 over, not 5 over 4, but 5 over 16. Don't worry, I'm going to show all the details, all the deeds. When I multiply square root of 5 over 4 times I square root of 5 over 2, the square root goes away, so I'm going to have a 5i, so I'm going to write minus 5i, see? And then what's 4 times 2? 8, so there it is. Then when I jump into this middle one here, that's it. I've already exhausted the square root of 5 over 4 with both terms on the other side. Now I jump to the middle one here, and I multiply by this one. So again, I'm going to have a minus 5i over 8. Do you see how it's the same thing again? Okay. And now this one times this one. I times I. So plus I squared. Square root of 5 times square root of 5. 5. So I'll put the 5 in the front. So 5i squared plus 5i squared over 2 times 2. 4. How do we feel? All right. Don't worry. Don't fall asleep on me. These right here in the middle, combine like terms. Negative 5i minus 5i, I have 2 of them, so that's going to be, minus 10i. I heard someone say it. Minus 10i over 8. Can I reduce that? Okay, I will reduce it later. Yeah, we can. That I squared turns to a negative, guys. So minus 5 fourths. Okay, the 10 and the 8 right here. 2 goes into 10 5 times, and 2 goes into 8 4 times. So I'm going to change this. So let me write the equal sign. 5/16 minus 5/4 with an I on it minus 5/4. You're almost done. I'm just being silly here by extending it because I want you guys to see all the details. I'm going to add up these two guys, but before I do that, I need to get a common denominator. So I'm going to multiply this right one by 4 over 4. So times 4 over 4. That's just 1. So anything you multiply by 1 is itself. So this number here is going to turn 5 times 4 is 20. And then 4 times 4 is 16. So there it is. So now I can add them both together. 5 minus 20, negative 15 over 16 minus 5/4 with an I on it. And there it is. This one didn't have a radical. You could check it. Let me see. You could check it with this guy. Equals. I already forgot what the problem was. What was it? Square root of 5 over 4? Square root of 5 over 4. Was it minus? Minus square root of 5 over 2. minus. Sorry, guys. Sorry. So here is what power was it squared? Did we get that? Chubb, I don't know. 0.9375. That is. Tell the calculator to give it a fraction. And it should. There it is. Negative 15 over 16 minus 5 fourths I. Is that what we got? Yeah, we got it. Good job. Last one. Last one. I think this one's going to have a radical in it. All right. Or irrational. Or we'll see right now. 3 over 2 plus square root of 7. I'm going to put the I here in the front of that. Over 3 times the same thing. 3 over 2 plus I square root of 7 over 3. Okay, you guys ready? Here we go. Last one, and then we'll set you guys loose. 3 over 2 times 3 over 2. 9 over 4. Are we still okay? Okay, and this one, I'm not going to shortcut it, guys, because maybe the square root's going to mess you guys up. Hey, focus, guys, focus. So I'm going to multiply like that. So I'm going to write plus, and I'm going to write 3i square root of 7 over, and then 2 times 3 is 6. I could put the I in the back, but I just think it's easier for me like that. I don't see any issues. I'm going to multiply this one inside now. It's going to be the same thing. Plus 3i square root of 7 over 6. We're still okay. And then I squared of 7 over 3 times I squared of 7 over 3. So I'm going to write plus I squared, and then square root of 7 times square root of 7 is 7. So I'll put the 7 in the front like that. See? And then 3 times 3 is 9. I'm going to add these two here in the middle up. What's 3i plus 3i? So leave that square root of 7 alone. So you're going to write it like this. I'm going to write 9 over 4 plus 6i square root of 7 over 6. Yes, we're going to delete the 6 in a little bit. Plus, and then that I squared is negative 1. So instead of plus, I'm going to write, minus 7 ninths. Is everyone here? Yeah. All right. These 6's cancel, the ones in the middle. We're almost done. We're almost done. I'm going to get a common denominator. I'm going to multiply the right one, the 7 ninths, by 4 over 4. I'm going to multiply the left one, the 9 fourths, by 9 over 9. So let's see what we have. We have 81 over 4 plus I square root of 7 minus, and 7 times 4, what's that? 7, 14, 28. 28 over, oh, it's not over 4, right? What's 9 times 4? 36. Sorry, guys. 36. Yeah, I make mistakes all the time. No, you're good. You're good. No, it is early. All right. My final answer. The difference between 81 and 28. Well, let's see. 81, 71, 61, 51, 52, 53. 53. So I see 53 over 36 minus I square root of 7. The textbooks are probably going to write the I in the back of the square root of 7, but sometimes that square root stretches too long, and you include the I in there, so that's why I decided to put it in the front. Is that okay with you guys? Oh, is it? Oh, yeah, plus. Thank you, miss. +1. Yeah, I make mistakes all the time. On the video, I'm going to delete that part, so it's going to look like I didn't make a mistake. No, I'm kidding. I'll leave it. All right, guys. Take care of the Delta Math. You got a Delta Math on this, and we'll call it a day. Rodriguez, what do you think?